This video has been prepared by EPB Center team in the context of a service contract for the European Commission. This video is part of a series dealing with the basic concepts about energy performance in buildings. The video on exported energy highlights that there are two ways of accounting exported energy. According to the resources used to generate it, this is called option A and is selected with K exported equals 0. According to the avoided use of resources of the external grid generators, this is called option B and is selected with K exported equal 1. This video details the effects of selecting option A. A similar video details the effects of selecting option B. The first example is a building heated by a heat pump. This diagram shows the energy flows for this simple building. Here is the seasonal energy need for heating. The required heat output of the heat pump is somewhat higher because of distribution, emission and indoor temperature control losses. The heat pump captures heat from the environment and needs 1000 kWh electricity input during the heating season. Some electricity may be supplied by on-site PV panels. The rest is guaranteed by the grid connection. This table demonstrates the calculation of the energy performance. There is one line for each delivered or exported energy carrier. This column shows the actual amount of the delivered or exported energy carrier. These two columns show the primary energy conversion factor of each energy carrier, non-renewable and renewable. And these two columns show the actual amount of non-renewable energy or renewable energy which is delivered or exported with the energy carrier. This column shows the total primary energy, which is the sum of non-renewable and renewable. And this last column shows the renewable energy ratio. That is the ratio between renewable energy and total primary energy for each energy carrier, or for the relevant results. To handle in a practical way option A and option B, the calculation procedure in EN ISO 52000-1 is organized in two steps, Step A and Step B. But for option A, only Step A is required and Step B is grayed out in this table. And the final result is just a copy of the result at the end of Step A. Please have a look at the video on option B to see Step B in action. The second line of the result is the energy available externally. Now there is no, because all the delivered energy is used inside the building. As shown now in the diagram, PV production is less than the electricity required by the heat pump, so there is no exported energy. The calculation of primary energy is quite straightforward, because you just sum contribution for each delivered energy carrier. No option needed, A or B, just a conversion factor. Please note that all energy flows feeding the technical systems are considered as delivered energy. This includes connection to on-site PV panel, connection to the grid, and energy captured from the environment. Let's start our simulation with zero contribution from the PV panels. So the heat pump is running on grid electricity, there is non-renewable energy used, but also a lot of renewable energy, mostly because of environment heat which is captured. Please note that the renewable energy ratio is already high because of environment heat. Now let's simulate a higher contribution by PV production. Of course, the grid contribution will decrease, so the non-renewable primary energy use will decrease, and the renewable primary energy use will increase, up to the point where PV is providing the whole electricity input for the heat pump. So there is no contribution from the grid, and the renewable energy ratio is 1 because there is only delivered energy from PV and heat captured from the environment. If the PV production exceeds the heat pump input, then exported energy appears. Since we selected option A, we will evaluate the exported energy with the same conversion factor as the corresponding delivered energy, in this case PV. The excess PV production comes in and goes out, that is delivered and then re-exported with the same weighting factor. So import and export cancel out and there is no effect on energy performance. Even if the exported energy increases a lot, there is no change in the energy performance and the renewable energy ratio stays constant as well. Since the exported energy has no effect on the energy performance of the building, we state this by saying that the exported energy is not part of the energy performance. It is reported indeed as energy available externally, since it has not been used in the building. More, if you select option A, except for very special cases, the renewable energy ratio is always in the range from 0 to 1 and the energy performance is always a positive number. Now let's have a look at the second example. It is the same building with the same heating need, which is now heated by a gas boiler. So the main energy carrier is now natural gas. PV may contribute only by powering auxiliaries. If PV production is low, then the grid will back up and supply the missing electricity, as shown. Looking at the energy performance calculation table, there is one additional row for the energy carrier natural gas now, which is the highest contribution and is mostly non-renewable. Again, if we increase the PV contribution, grid electricity will be replaced progressively by PV, and this will make little change on the energy performance since we can only contribute to auxiliaries. Even if PV production is increased a lot beyond the required electricity input for auxiliaries, no further change happens on the energy performance, because with option A, the excess delivered PV electricity is exactly compensated by exported electricity to the grid. The consequence is that there is no possible cross-compensation between different exported and delivered energy carriers. For example, the excess PV electricity in this case cannot compensate the use of natural gas. This is a consequence of selecting option A. The video on option B will show that it may happen when selecting this option. And here is a brief summary. There are two ways of accounting exported energy. If you select K exported equals 0, also known as option A, then the exported energy is not part of the energy performance of your building. The energy performance is always a positive number, so the renewable energy ratio is always between 0 and 1, and energy carriers are independent. If you select K exported equal 1, also known as option B, then exported energy is part of the energy performance of your building. Energy performance can be a negative number, renewable energy ratio can be negative or higher than 1, there can be a cross-compensation between energy carriers. See the dedicated video for details about option B. Both options are valid approaches. Choice between option A and B by a country is free, but it has consequences on energy performance value indeed. EN ISO 52000-1 allows to make this choice in a fully transparent way. This video has been produced under a contract with the European Union, represented by the European Commission. The information and views set out in this document are those of the authors and do not necessarily reflect the official opinion of the European Union. Neither the European Union institutions and bodies nor any person acting on their behalf may be held responsible for the use which may be made of the information contained therein.